Saxon's Trig, Lesson 14. Up to this point in the book, we have been doing a lot of geometry type review of rules. This lesson begins what is technically our first trig concepts that we're going to discuss. So it is the words sine, cosine, and tangent. Then they apply that with angles of elevation and depression, and then they shift gears to rectangular and polar coordinates, and finally coordinate conversion. So for part A, the terms sine, cosine, and tangent. They are applying to right triangles and right triangles only. So if I don't have right triangles, I cannot do the sine, cosine, and tangent. Obviously, I've labeled that 90. That means that this, opposite the 90, must be my hypotenuse. And I'm going to have to clarify which angle I'm talking about. So if this is the angle I want to deal with, this side is its opposite side because it's opposite that angle. This side is adjacent to this angle because they're sitting side by side. Now, sine, cosine, and tangent, I want a way to remember them. And there are multiple ways, but the one that I prefer says, it kind of sounds like an Indian phrase, so, ka, toa. Now, the book does sine is Oscar had a hold on Arthur. Now, I have to remember if I use that one, the order sine, cosine, and tangent in order to use Oscar had a hold on Arthur. When I do so, ka, toa, the word is embedded in. So sine means opposite over hypotenuse. Cosine means adjacent over hypotenuse, and tangent means opposite over adjacent. And that's how we solve for the fractions that you need. Okay, your book actually didn't do Oscar had a hold on Arthur. It did Oscar had a heap of acorns. So as I said, there are multiple ones of them. They also list the so, ka, toa. Okay, so now that we have the basics, let's move on to example 1. They give us a right triangle. This is 36 degrees. This is A, B, and the hypotenuse is labeled as 6. And it says solve for A and B. You're going to do for A is adjacent, so we're going to use the word cosine. So the cosine of 36 degrees is adjacent over hypotenuse. The adjacent is the unknown A, the hypotenuse is 6. And on my calculator, I then punch in, now, depending on what your calculator, which direction it wants it, some wants you to do 36 and then hit the cosine button. Some want you to do cosine button and then the 36. So you need to figure out how your calculator wants it. But when you do that, you should get 0.809 something or other. If you're getting in the ballpark of 0.809, you figured out how to work your calculator. Now, to solve for the A, you need to remove the 6 from the denominator. Because it's in a fraction, it's dividing, so the opposite to move it to the other side is multiply it. So you want to take this times 6, and that will solve for A. 6 times 0.809 is 4.854 or something along that line, and that's A. We still need to solve for B. What is B's relationship to the given angle? It is opposite. So which one uses the opposite with the known hypotenuse? Sine. So we're going to do sine of 36 equals B over the hypotenuse of 6. So again, on my calculator, depending on the order in which it wants it, I'm wondering if I just pulled that wrong number. Oh, I certainly did. Backtrack here, my apologies. They solved, oh, maybe not, hang on, let me check. I was doing A, right? 0.809. No, we're good. Whew, okay, for a split second there, I thought I had those backwards. Sine of 36, yep, here we go, is definitely 0.587. You could round that off. Multiplied with the 6 solves for B. B is 3.527 if I round it. And those are the answers for A and B. Okay. Yeah, they were solving it. I'm not going to worry about why they were doing that. Jump to example 2. We now have this right triangle. This is M, 7 as the hypotenuse, 3 and X. Now they want me to solve for angle M and side X. I do not have enough information currently to solve for M's degree because I don't know what this one's degree is. So I can't do the 180 minus 90 because I don't know what this guy is. It's not going to help me get to M. All right, so I'm going to have to use sine, cosine, or tangent. Just to kind of help you figure out how you solve these problems, I'm going to write down all three, even though I know I don't need all three to solve. So the sine of M would be so opposite over hypotenuse. That I can solve. Okay, but I said I'm going to write all three out. Cosine of M, ca, adjacent over hypotenuse. And tangent of M, toa, opposite over adjacent. So this one has two unknowns, the M and the X, same problem here. This one, as I said, I can solve for. So you're going to do on your calculator 3 divided by 7. So you get sine of M equals 0.428. Doesn't really matter how many decimal places you take it to. The more you do, the more accurate your answer is. So you do however you want to do. Usually students leave whatever the calculator length says and just jot down a couple of numbers on the paper. All right, so we have this, and we need to solve for a degree answer because this should be an angle in a degree. My calculator can tell this to me if I ask it in the right way. So before, when you knew the cosine and the 36, you knew the degree, you were putting it in directly with the cosine button. You should have associated with that cosine and that sine button something that either says cosine -1, it might say inverse cosine, just depends on what your calculator wants. You're looking for this type of thing, and it's usually you have to hit a second button, or some of them have a direct button that has this, but this is what you're looking for. When you find it and you do 0.428 inverse cosine, second cosine, however you get, sorry, not cosine, in this case sine, so you want to do sine -1 or inverse sine, same concept, but 0.428 second sine, inverse sine, however it works, your M should spit out 25.38 degrees. You can write that as 25.4 degrees. Again, there's no set rule for how many places you have to have. Once you figure how to work the inverse, the second, the shift, however that works for you, now you can go ahead and solve for the X. And we know what the M is now. So we could plug into either of these because they have the X. Let's just do the, well, since I'm pulling from the book. Oh, no, wait. Don't even have to do all of that. Even easier. Don't use all of those. Right triangle, I can Pythagorean theorem to find X, even easier. So 7 squared is 49, and that comes from 3 squared, which is 9, plus X squared. And then we minus 9. 40 equals X squared. We're going to square root both. So X equals I square rooted, so positive and negative must always be there. And then the 40 needs to split into however you split it. And a set of 2's, pulls to the outside, and the 2 and the 5 are left inside, multiplying together to make root 10. Now in this case, they didn't leave it in radical. They actually took it to decimal and said that that's 6.32. I don't know that there is a necessary preference for which way the Saxon book will do it. It could be either direction, and either way you give the answer. As long as I have the work that I can look to see, we're going to be okay with your answer. Okay, part B shifts gears to angles of elevation and depression. And this is going to use the sine, cosine, and tangent. So it's based on my line of sight. So as a person, wherever my line of sight is, if I am looking up at something, that's elevation. If I'm looking down at something, that's going to be depression. Example 3 on page 110 says that I have a man that is 6 feet tall who is 6 feet, I wanted to get that part labeled. He is 200 feet from a tree. 200 feet from a tree. Tree is obviously going to be bigger than him, and I am not an artist. So there is my tree. He measures the angle of elevation to the top of the tree. So basically I want to picture from his eyes up to the top of the tree is where I'm forming this triangle. So this line is still going to be 200. This part is the 6 feet. I do not know that part. What else does it tell me? Angle of, oh, it was 11 degrees, so I need to label that 11 degrees. How tall is the tree? So I need to find this line. I'm going to label it X, and then later I can add on the rest of the part, which is his 6 feet. Now, there is this argument that his eyes are not at the top of his head, and if he's 6 feet tall, for practical purposes here, they ignore that little discrepancy, and basically you have to pretend that his eyes are at the top of his head. Whatever. Okay, so the triangle that we have 11. We want its opposite, and we know its adjacent is 200. Which word uses opposite and adjacent? Tangent. So tangent of 11 is unknown opposite over adjacent of 200. So we're going to solve on our calculator tangent of 11 degrees, multiply by the 200, and you should get that it's 38.88. X is 38.88, and that's technically in feet. And then we add that extra 6 from the man, ignoring the eyeball difference, and that should give you a final answer for the height of the tree of 44.88 feet. Example 4 says an airplane is flying at an altitude of 3,000 feet above the ground. A pilot, and again, you're going to argue that he's in a plane, the plane and the pilot may be slightly different, whatever. Okay, so I got my little pilot in here. All right, so he's looking down at something. Sights an object on the ground at an angle of depression of 26. Okay, so this is saying he's looking down at 26. 26 degrees. What is the slant range from the airplane to the object? From the plane down to this object, this is what they want me to find. How long is that? Now, I have potentially 2 different triangles here. If I finish the triangle here and connect those two, and I'm just going to draw a dot for my object down here, this would also be the 3,000 because it's the same distance as I labeled it here. And if I do that, I can use the 26 degrees. Now in the book, they put the triangle here, and that's obviously still the 3,000, and they stop and find another degree for this angle so that they can solve with the number here. It doesn't matter which way you do it. You'll get the same answer either way. But if you are following the book or you ever need to do this, what kind of an angle is here? Well, that's 90 degrees. So 90 minus the 26 gives you that this would be a 64 degree. Okay, so back to our sine, cosine, and tangent. We know a degree. We want to find the hypotenuse, whether I use whichever triangle I use, x is the hypotenuse, and I know the opposite if I'm using this one, or if I'm using this one, it's the adjacent. So on this upper triangle, I know opposite over hypotenuse, that's sine, so sine of 26 is opposite 3,000 over hypotenuse x. If I am doing this one, I am doing adjacent over hypotenuse, so cosine of 64 equals 3,000 over x for the hypotenuse. Now, a quick note here, the reason this works no matter which triangle way you're doing it is because sine of 26 and its opposite cosine of 64, because 90 degrees kind of makes them like mate degrees, this will always work because of that relationship. All right, so on your calculator, you're going to do sine of 26 degrees. Now, I may have to use theirs because I'm pulling the numbers from the book and not actually punching this on a calculator. So I'm actually going to do this one since they're giving me that number. So the cosine of 64, oh, did they give that individual number to me? Oh, they did not. Okay, all right. Doesn't matter which way I do it then. I'm going to come back over here. Sine of 26 is going to give me some sort of number, and that equals the 3,000 over x. How do I remove the x from the denominator? I multiply it over here, which means whatever that number is multiplying with x, and the problem equals 3,000. Then to solve for the x, I then divide by this number. So this is an extra step in order to solve here. And it should come out 6843.52 feet, no matter which way I do it. And then same kind of thing is going to happen here. You would get a number, you would multiply it by the x, you would take the 3,000 divided by that number and still get your answer. I'm going to pause or stop the video here and actually do section C and D in another.